All right, good morning. We are going to start here on, we're actually going back into chapter 2. So this is your bell work, and you can go ahead and pause the video and try this out for a second. It should be up on the board for you already, but if not, go ahead and pause and give this one a try, and that is complete the square for this problem. All right, hopefully you have paused and given that a try. So now we're going to take this thing and complete this square. And the reason we want to complete this square is so that I can get it into vertex form. Okay, and we only have one side here. So we're going to look and isolate these terms right here. We're going to isolate those. So we've got a 3x squared minus 6x plus blank plus 4 minus blank. We're going to add and subtract on the same side. I got to take this 3 out. So 3x squared minus 2x plus blank plus 4 minus blank. To figure out what goes in the blank, we're going to take our b over 2 and we're going to square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. But remember, I have this 3 out here, so we're multiplying by a 3 over here. Then we're going to continue and factor this. So 3x minus 1 squared, and then plus 1, because 4 minus 3. This is your completed square. This is your vertex form. So the vertex of this thing is at 1, 1. The leading term is positive, so it's going to open up. Okay, we can also say that it moved right. It got vertically stretched by 3, and it went up 1. Okay, so this is kind of review a little bit of what we've done. And actually, chapter 2 in our book, which is what we're going through now, we've done a majority of that. So that's what we're going to look at now. So 2.1 is quadratic transformations. Our goal here is to describe and graph quadratics using transformations. So last chapter, chapter 3, was all about solving and factoring. And now we're really going to look at the graphs of those parabolas. All right, so we have this equation here. Y equals a bx minus h squared plus k. We're changing this. This is our new parent function. Okay, and remember the song. So you're actually going to sing in class. The sub will, I'm going to give them a specific time to start singing, and then you guys will lead through that song. If you need the song, I have it all right here on this next slide. So you can sing through it. And the important parts are down through here with what every letter does. Remember, we got to follow the order H, B, A, K when we're done. So go ahead and pause the video and sing it a couple times through so that we can re-look at that and remember it. All right, hopefully you got through that song okay. We will definitely be singing it when I get back into the classroom. All right, so we have to remember the parent function, and that parent function is y equals x squared. We've talked about this parent function, but if I just pick some xy values, we're going to say negative 3, negative 2, negative 1, 0, 1, 2, and 3. If I pick those x values, I can just plug them in right here and get the new y value. Anytime you have an x and need a y, just plug it in. So negative 3 times negative 3 is 9, and then you get 4. 1, negative 1 times negative 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4, and then you get 3 squared is 9. So we're going to plot those points. We have 0, 0, 1, 1, negative 1, 1. Remember I talked about the symmetry we have here, 2, 4, and negative 2, 4, and 3, 9, and negative 3, 9. And this is a parabola. It has a gentle curve down here. Okay, parabola. It has an axis of symmetry that we've not really talked about, but you should know the axis of symmetry runs right down the middle of it. Okay, making everything that happens on this side the exact same of the left side. Okay, and we've been moving these 5 points here up, down, left, right, and that's what we're going to focus on here in this lesson. So graph and describe the transformation. Okay, so we've got g of x equals x plus 4 squared minus 1. So our parent function is x squared, meaning it's that parabola. So 0, 0, 1, 1, 2, 4. And those are enough points for me. I just reflect those over. This is what I'm moving. Then we've got h, b, a, k. So h is this number in here. So h in the equation goes left and right. Negative right, positive left. So this one is going left 4. There is no b, there is no a, and then the minus 1 goes down 1. So if I take these 5 points here, and I'm going to go left 4, 1, 2, 3, 4, and down 1. There's that. And then I can do the same for all these. 1, 2, 3, 4, 1. Reflect that one over. Okay, it's just 1 away from your vertex here. And then 1, 2, 3, 4, 1. That one is 2 away. And that 2 away, 1 away kind of changes when you start stretching these functions. So then here is your graph. Whoop, I missed those points. But we've got them dotted there so I can see them. Down the road, we're going to look at domain and range, so we might as well start. So the domain of this, how far left and right does this graph go? It actually goes negative infinity to infinity. Any x squared will cover the entire graph. Range is the y values, so the lowest y value I can have here is negative 1, and I can actually have it. And then the tallest one, or the highest y value I can have, is infinity, because that thing keeps going up. So describe the transformations and graph again. So just kind of put the dots here of our parent function. We've got x squared on both of these. Okay. Now with this one, so parent function is x squared, h, b, a, k. Okay, I don't have anything in parentheses here, so that means I don't have an h and I don't have a b. If you have an h and b, they will give you parentheses in the problem. A is this one out here, so it's a half and it's a negative. So A is going to compress, a vertical compress by half or by 2, and then it's going to flip over the x-axis. Okay, so if we do that one, we're not moving it left or right any, we're just compressing it vertically by half. So that's when you take all these y values here and divide them by half. So let's just look at the negative 3, 9, and 3, 9 as well. Okay, so if you take 0 divided in half, it stays. Let me switch colors. 1 divided by half will go to a half. 4 divided by half is 2. And 9 divided by half is 4.5. So 2, 3, 4.5, and 4.5. So we've kind of shrunk this parabola. It's going to look, I mean, it did get wider, okay, but we're not pulling it apart. We're actually taking it and pushing it down because it's a vertical compress. And with this one, there is no d value because I don't have a plus or minus over here. With this h of x, we have our parent function is still x squared. Now I do have parentheses here, so I will have an h or b. Okay, so there is no h because there's no plus minus. B, this is a horizontal compress by 2. Okay, because inside of the parentheses, it does the opposite of what you think it does. So normally we would say a 2 stretches it, but since it's inside the parentheses, this 2 is actually going to shrink it left and right. There is no a out here, and then k is a plus 1, so we're going to move it up 1. Okay, so we're going to start with these dots right here, and we're going to horizontally compress them by 2. So we're taking the x values and dividing them in half. So this is still 0, 0. That one's still going to stay there. This 1 divided by 2 is a half. So we got there and there. 2 divided by 2 is 1. So those are going there. 3 divided by 2 is 1.5. So it's going right there and right there. And this is not the end, so let's pause here. Now we're going to move everything up 1. So 0 goes up 1. These 2 dots go up 1. This dot goes up 1. And this dot goes up 1. Okay, be careful with this. Maybe erase or use some different colored markers or pens or something. So here is your parabola. Now again, with the parabola, it looks like we just stretched this thing up. And you can actually get the exact same thing by stretching it up versus stretching it left and right with a parabola. But moving on down the road in math, it's not going to look the same. But we definitely want to practice with some of these easier functions. Okay, and we can look at domain and range for both. Remember that the domain of each is all reals. So even this one doesn't matter. And the ranges will be the ones that change. So with this first one, it was this green one. We start at 0, and I can have 0 to infinity. Oh, you know what? We forgot to flip this green one over the x-axis. I just noticed that. Okay, so let's go back, and we're going to flip it over. So it was at a half, so now it's at negative a half. And then 2, so down 2. And then this was what, 4.5? So 2, 3, 4.5, 4.5. So right here. So this is actually the correct graph, not this one up here. That one should have been dotted. Okay, which changes our range. I forgot to do that. So the smallest is negative infinity to 0, and I can have that 0. So it just flips the order around. And then the range here, I wasn't supposed to flip it, no. The smallest is 1 to infinity on that one. So be careful, make sure we flip that. You can make the mistake just like I did. Okay, so write an equation for a quadratic. So that tells us the parent function that was vertically stretched by 2, reflected over the x-axis, and shifted down 3 units. What is a vertex? Okay, so we have our parent function. We can kind of work these backwards. H, B, A, K. I don't believe I have a horizontal stretch, but I do have, a horizontal shift. Do I? Just moving 3 units down. So 3 units down is K, so that's a minus 3. No left and right. No horizontal movements for B. I am vertically stretching by 2 and reflecting over the x-axis. So that means A is going to be negative 2. Okay, so we have our parent function. Let's just say f of x equals, I have an A of negative 2, x squared. There's nothing in there because there's no B and no H. And then we're going to go down 3, so minus 3. If you want, you can write it like this. So negative 2x plus 0 squared minus 3. That might help us find this vertex, because now this is in vertex form. So I have 0, negative 3 for the vertex. Okay, because I didn't move it left and right any. I just shifted it down 3 units. Let the graph of G be translated 3 units right and 2 units up with a reflection over the y-axis. Okay, so this one changes just a little bit because now this is the function that I have. Okay, it's not the x squared parent function. So we have to remember that when I translate left and right, that number goes inside of the function. Okay, and it will actually be a minus 3 inside of the function. So we'll have x minus 3 inside of the function, but then this 2 units up goes outside the function as a plus 2. So here's my function, and inside of it, I'm going to put x minus 3 everywhere you see an x. That gives me the 3 units right. And then on the outside, we're going to put this plus 2 because that just shifts it up 2. Now we're going to reduce this. We've got to FOIL this. This means x minus 3 times x minus 3. We did have a shortcut for that, and that was square the first, multiply all 3 together, so negative 6x, and square the last, so plus 9. Then distribute this minus 5, so minus 5x plus 15, and then plus 2. Combine like terms, so I don't have any x squareds. Minus 6 minus 5 is minus 11x. And 9 and 15 is 24, plus 2 is 26. So this, if I take this thing and move it right 2 units and up, or sorry, right 3 units and up 2 units, it is the same as just graphing this equation right here. Okay, so if I take this and move it, it is this equation right here, and that's kind of what we want to look at. Okay, last slide here, a word problem. The height in feet of water spraying from a fire hose can be modeled by that equation, where x is the horizontal distance from the fire truck. The crew raises the aerial ladder so that the water hits the ground 10 feet further from the fire truck. Write a function that models the path of the water. Okay. So we have this function, and it tells me the crew raises the aerial ladder so that the water hits the ground 10 feet further from the fire truck. All right, so sorry about that. So we want this truck to hit the ground 10 feet further from the fire truck. So the first thing I have to do is understand that we're shifting this ladder up so many feet. So I got to figure out how far up I need to shift this equation right here. Okay. In order to do that, I have to figure out where the water is hitting the ground right now. So we need to say that 0, let me go ahead and do this. 0 equals negative 0.03 x squared plus x plus 25. I need to figure out where it's hitting the ground right now. So you can probably factor, complete the square, whatever. Let's just use the quadratic formula. So x equals negative b plus minus the square root of b squared, which is 1, minus 4a c all over 2 times a. Okay, so we're going to put this into the calculator. So negative 1 plus minus 1 minus 4 times negative 0.03 times 25. So So that's plus minus the square root of 4 over 2 times negative 0.03 is negative 0.06. So this is negative 1 plus minus 2 over 0.06 negative. So you get negative 1 plus 2 divided by negative 0.06, which you get negative 16.67, which you can't have. Negative 1 minus negative 2 divided by negative 0.06. Whoop. Negative 1 minus 2 divided by negative 0.06 is 50. Okay, so right now, this truck water is hitting the ground at 50 feet. Okay, but I need it to be at 60. Okay, so what we need to do is I need 10 more feet would be 60. So I need this thing to be hitting at 60. So in order to figure out how much this thing gets raised up, we need to find what h of 60 is at right now. Okay, so I'm going to plug in 60. So negative 0.03 times 60 squared plus 60 plus 25. So if I take negative 0.03 times 60 squared plus 60 plus 25, is negative 23. Okay, so when I plugged in 60, I see that 60 right now is at 23. So in order for that point to become a 0, I have to shift this thing up 23, because at that negative 23, I got to go up 23. So shift up, so go up 23 units. So we're going to take this right here, and because it's a shift, it's a k outside of the function. We're outside of the function. We're just going to add 23 to this. Okay, so 25 plus 23 makes 48. So our new function, h of x equals negative 0.03x squared plus x plus 48. That will ensure that when I move this ladder or this water up to get it to go out to 60 feet, 10 foot further, I have to go up 23 feet, and that is this equation. And if we plug in 60, h of 60, we will get 0. Okay, if I plug it in here and here, you will get 60. All right, you've got some homework on big ideas, and we'll see you later.